Okay, this is week 13. This is the part 2 video. Factoring trinomials on this first part. Just like what you would factor any number, this would be, say, 2, this would be 3. Notice that means multiply. Factors mean two or more things that multiply. Well, for trinomial, we can extract some numbers by a simple pattern. You take the first thing, p squared, well, that can be factored to p times p. And you put those two factors on the left side of each parentheses. Then you take the number on the far right and factors of 48 will go here. Those two places. The problem is 48 has several factors. Well, which is it? There's 5 sets right there. This is how you know. The factors multiply to be 48, but they add up to 14. 48 and 1, nope. 24 and 2, down here at 8 and 6. Some of you got that as soon as I said they have to add up to 14. There you go. So if we come over here, we take factors of negative 28 that have to add up to negative 3. I'm going to do the two sets of parentheses. So r times r. This is a negative, so one of the factors will be negative, one of them will be positive, but the bigger one must be negative because when they add up to a negative number. So there's negative 28 and 1, nope. Negative 14, positive 2, nope. Negative 7, positive 3, positive 4, I mean. And yep, those two add up to negative 3. So negative 7, positive 4. All right, so that's how you factor basic trinomials. Once in a while you're going to get a quadratic that has this plus 0 over there. And all that means is that when you go to graph it, it's going to cross. It might look something like this, where it crosses through the origin. Okay, well, we've already practiced these. These both share an a, so we're going to put an a on the outside. Well, that's a to the first. 2 subtract 1 leaves a to the first. 10a divide a leaves 10. So that's all you're doing on those. Now, when we come down here, when you have a lead coefficient, normally, so far we've just been doing it whether it's had the invisible 1. When the lead coefficient is not 1, what the first thing you want to do is you want to ask, does 2 go into all 3 of those coefficients? And it does. So we're going to factor out a 2. 2 divide 2, the 2 cancels. 6 divide 2, the 6 cancels, and now you have 3x. 20 divide 2 leaves, subtract 10. And that's how that one factors. But we're not done, because now we have a trinomial. Factors of negative 10 that add up to negative 3. And whoops, there we go. So the x's go here. If this is negative, then I'm going to say negative 5, positive 2. They multiply to be negative 10, but they add up to negative 3. And notice it doesn't matter which order. I could have put the subtract 5 and the plus 2 over here. That part doesn't matter. So notice these all have a 4 in common. So you'd first factor a 4 out, and then you do your 2 sets in parentheses. All right, let's come down here. Now we're going to deal with special relationships. Okay, notice subtract sign, well, that's called the difference. Subtract is the difference of two numbers. This is a perfect square, and this is a perfect square. And so this special relationship is called the difference of squares. And it factors to, difference of squares factors to what we call conjugates. What are called conjugates? Means the exact same thing, the numbers and the variables are exactly the same. The only thing that's different, one gets a subtract and one gets an add. It's the only difference. So you're going to take the square root of that first thing, and you're going to put it, since this is on the left side, you're going to take the square root and put it on the left side of each parentheses. Well, the square root of 25x squared, well, square root of 25 is 5. The square root of something squared, the square root cancels, leaving an x. So 5x. Then you take the square root of the second thing, and notice, only difference is one will be subtract, one will be add, and these are called conjugates. And to check your work, because some of you have asked that before, go ahead and do the distributive. 5x times 5x is 25x squared. 5x times positive 2 is 10x. Okay, we're done with that. And then negative 2 times 5x is negative 10x. And negative 2 times positive 2 is negative 4. But look at this in the middle. You have a plus 10x and a minus 10x. Those two zero each other out. So what we're left with is 25x squared, subtract 4. So that's how you know you did it correctly. All right, I'm going to erase all this and get that out of the way. Just because I'm going to be saving this note sheet and I don't want this stuff in the way. Well, all right, I'm going to leave that there, I guess. Nope. All right. So, notice 18 is not a perfect square. Neither is 50, but these both have a 2 in common. 18 divide 2, you're going to be left with 9r squared. 50 divide 2 is 25. And now these two are a perfect square. So you're going to put your two sets of parentheses, put one subtract, one add. The square root of 9r squared is 3r. The square root of 25 is 5. That's the work that you would show me. Now we have something different. This is a perfect square. This is a perfect square. This special relationship is called a perfect square trinomial, and it factors to a binomial squared. Meaning something squared means what goes in the parentheses, these two things are the same. And because they're the same, you can just write them as squared. So here's this pattern. You take the square root of the first and the third items. So 3p. But these both get, so notice those are identical. We don't need this. We can just square it. That's all the work. However, you must do the check, and this is the specific check. 2 times 3p times 5. 3p times 5 is 15p. 2 times 15p is 30p. Yep. And the reason why I say you must do the check, what if you had one on a test? Well, that's a dilemma. This is a perfect square and this is a perfect square, but this does not factor to this, because when you factor this, the middle term is supposed to be 30p. So this is the only perfect square trinomial when you have 9p squared. This would not factor. You'd probably have to use the quadratic formula for that. So you've got to do the check. First thing we're going to do here is see how all of these have a 4 in common? We're first going to factor out the 4. So that leaves 4 divide 4 leaves 1. 16v divide 4 leaves 4v. 16 divide 4 leaves 4. This is still squared. This is still squared. So it's a perfect square trinomial. And let's see if it factors to a binomial squared. So we're going to take the square root of v. We're going to take the subtract operator because that's the first one. And the square root of 4 is 2. And then we're going to do the check. 2 times v times negative 2. Well, negative 2 times v is negative 2v. 2 times negative 2v is negative 4v. And this negative 4v times this 4 does equal negative 16v. So this is correct. All right. So now we have to find the product. Well, remember, something squared means this thing times itself. This also has a special pattern that we're going to find in a minute. Once you understand the pattern, you won't have to show all of this work. So we're going to FOIL it. The 2 first terms multiply to be 49. So that's the first part of the distributive. The second part of the first item distributing would be 7 times 7n is 49n. Well, those are the 2 outers. And we're going to skip to the inside ones. 7n times 7 is also 49n. And then 7n times 7n is 40. Those are the 2 last, 49n squared. Well, look at what we have. 49 is 7 squared. These 2 things, there's 2 of them, and those 2 are 7 times 7n. And then this is 7n squared. Well, look at that pattern. It's the first thing squared. It's the second thing squared. And then it's 2 times the first times the second. And that's what we got right there. And that simplifies to 49 plus 98n plus 49n squared. Right, so let me show you the work that I'd expect to see. You can either do it this way, if that makes it easier, or notice that that's 7 squared is 49. 7n squared is 49n squared. If you have to, just do this part. 2 times 7 times 7n. Well, that's 49n. 2 times 49n is 98n. So if you can see the pattern and know how to use it, you can just use the pattern. You don't have to do that extra work. All right, that's it for this one.